KEET TV presents Homework Hotline, the after-school show that fuses learning with fun. Watch local teachers bring the classroom on air and online. This is Homework Hotline.
Welcome to Homework Hotline. My name's Pam Halstead, and I taught science at Fortuna High School.
My name is Amy Taylor, and I teach 7th and 8th grade math at Sunnybrae Middle School in Arcata.
We're so happy that you guys have joined us on the show. Yay, we have an amazing show that Amy has all lined up. Look at all this stuff.
Yes, prisms.
How can you beat it? Prisms.
Prisms.
What is a prism, Amy?
A prism has what's called two congruent, which is the same size like your hands, and they have to be parallel, so when we pull them apart, equidistant for forever. So
can we use this as an example? All right, go ahead. These are two congruent.
Two congruent parallel bases. It's a prism.
Okay, nice.
So we're done.
And that's it. Whoa!
And that's what all of these are, because even I guess I found this is like an ender eye or etc. But it's still a prism because it has two, from Minecraft, two congruent parallel bases.
That's right.
But I just, as you see, I have 3 teenagers, and this is stuff from our house, but they're, you know, an exit game that are fun, some DC characters. I did bring in cylinders, are technically not prisms, but what people do, it's these two, is they still have congruent parallel bases. It's just that they are circular, so they call them cylinders. But when you learn how to do things like volume, which is base area times the height, I like to scoop those in because you're really not doing anything different in any of these. You're doing your base area and it's looping up evenly up to your height to find your volume. So I don't like to separate it because a circle is just a circle. You can find that area just like you can find a rectangle or triangle. So
neat.
That's what we're going to do today.
Excellent.
And I was going to say, I hope everyone had a nice spring break. I think all those have passed at this point. So hopefully people had, all the students watching. I was just thinking that probably is over now. So cool.
Very fun.
All right. So Pam is going to pick something first.
I'm picking this, the flash.
The flash. Nice. So we are going to measure and do volume. Now the cool thing about rectangular prisms, that means there's a rectangle as a base. You can actually do it 1, 2, 3 ways because it has 3 sets of congruent parallel bases. But since we'll do it like right side up.
Okay. All right. Sounds good.
For purposes. So we're going to measure the top.
Okay.
And I'm going to put stuff on the whiteboard.
All right, so here we go. Would you like me to?
Yeah, we'll probably do, I think, I'm going to do centimeters because I can crank that down when we do other shapes.
Sounds very good. So I will start then.
And we can do point, blah, blah, blah.
The long part of this.
Yes.
Looks like it's 11.7.
Yeah, whatever it is, because we're going to have calculator too.
Okay.
All right, I'm going to start writing on here. We're going to do both. It's going to be interactive both.
All right.
So we're going to call this our, we'll call it rectangular prism because it is. Rectangular prism, you just basically, a prism has 2 congruent parallel bases, and then the rectangle, you name the base. So we're going to do the base area is going to be a little base times height, and we just got 11.7 centimeters, is that what we said?
Yes.
And we're going to multiply that by?
By the height?
Yes.
Okay. Ooh, the height of this thing is 16.
Yes, 16 centimeters.
Right, and we're doing centimeters, which she wrote down, which is very good, the units.
All right, and then we can pull out our calculator if you want to just work together. This is a lot of different calculations, but it's pretty cool. 11.7
times 16.
And we're going to use that base area for
187.2.
Nice. So the base area is 187.2, and then it's centimeters squared. Now what's cool is we can use that base area for both our surface area and our volume. So I'm going to switch colors, and we're going to do volume. So volume is always base area times height. So that's this base area, and typically they call it big B. I've seen capital A too, but I've mostly seen capital B. Times the height of the whole entire prism. So this is a different height, but we'll keep going. So volume is base area, which is 182.7 centimeters squared, times we need the height of the whole prism.
The height is this what we already just measured?
You were supposed to. No, we did the base area like this.
Oh.
Then we times it by the
All right,
height.
well, let's do it.
We
let's
could
do
it.
this.
This
We're
is,
gonna,
it's
here we
all
are.
good.
This is how it works. When you have
This,
someone
we
who has
are.
all right,
It's
so
all good.
let's do our base area one more time.
So we did 11.7.
Because I'm doing this now, which is
Yes.
8.5.
That makes more sense.
Okay, good.
Yes, that makes more sense. What does you say?
8.5.
This is 8.5.
Yes.
Okay. All good?
Yes.
Well, we also know that our.
Oh, I'm going to do
What's cool is that we'll know. Yeah, go ahead. Then we know this height of the whole thing has to be 16 now, which makes sense because it's taller. We can see that this is taller.
I have 99.45.
That's this one?
Yes.
What is it, 99?
99.45.
We'll just round it to half.
To 5, yes.
I'm going to do approximate instead since I'm rewriting it again.
Okay.
And now
Nice.
for our blue.
Now I'm gonna take.
I just, it looks awesome.
It's all right, right? Yeah. Oh, it's hard to write over that. Good job,
So
Amy.
99.5 centimeters
Times
squared
16.
times 16
Okay.
is about,
Okay.
that will be our volume of our whole thing.
1591.2. 1591.2
centimeters, and this will be cubed.
times 16.
That makes sense.
No, I don't. Yes. Well, it's why does it now? It says 1592. Is that?
So we think we rounded. So we
Okay.
did. So you did. So you said it was 8.5 this way.
I did 99.5 times 16, and that here it might have been because I was not. Is
No,
that
it's
right?
all good.
Okay,
It's
good.
all good. It doesn't matter. It's
close enough.
8.5 times
15.9.
11.7. We did 99.5. You probably did the 0.45.
I might have. I
99.5
think I
times
did.
16.
You're right.
Yeah.
Okay.
Which is all good.
Okay.
It's all good. I just
Sweet.
rounded more.
Okay, good.
We'll do 2. Race. Perfect. Here we go. And 2. So what we want to think of is that square centimeters are like just that kind of I think of a centimeter. I think of like my pinky, like nail. And then you do it in all 3 directions. So it's like this little cubic centimeter, and there'd be 1,591 of those. Then if you want to do the surface area where you'd like, if you dipped it, say, in paint all the outside, we still can do 2 of these bases, but now we're also going to need 2 of these bases.
And 2 of these
And 2 of
bases.
these bases.
Okay, cool.
Yeah, so
all right, let's do that.
we're going to do surface area now.
So we know the one on the top or the bottom, whichever you said the base. So we know that one.
Total surface area, which is total TSA, total surface area. I'm used to using all those acronyms, and it's like, wait, but you might not know what that is. So then we have 2 of the big base, plus we're going to have 2 of the other side.
2 of the others, but we need to know what they are, correct?
Yeah, sometimes I do this where I like just draw the rectangle.
Oh.
Plus 2 of the other rectangle.
Oh, yes. That's good.
There we go.
Now we can put numbers in for those rectangles?
Yes.
Okay, sounds good. We have 16 and times 8.5 because that's something we already... Well, I mean, I measured accidentally. Remember when I did the height of the thing?
Oh, yes,
so
yes.
we're doing
so
this
the
one.
16 times 8. Oh, we already measured
8.5.
everything then.
I know, it's beautiful.
We did. 16, 8.5.
You know what? Yeah, my measuring it again looks almost like it's closer to 9. But
It's okay.
Okay,
It's
call
all
it 8.5. It's all good. Okay. Sweet, sweet.
And now we need the front
now
and the
we'll
back,
do the big
right?
front and the back.
So
yes.
we need, it's going to
Okay,
be...
it's going to be 16 again. That's because that's the height period.
And times 11.7?
Sure. We'll
the
call
one
it that, say 11.5, but 11.7 is good.
We're going to use the same thing.
Okay.
So now we just need like all these numbers. So we have
Yes.
2 of our bases,
Okay.
which is 90. What's our base? 99.5.
99.5.
But then we need 2 of these. So what's 16 times 8.5? So 2 of the side areas.
To the side areas here.
2 of this. So we need 2 of these. So we need 16 times 8.5.
16 times 8. No, I did not. Hold on.
16 times 8.5, right? This is the 8.5.
Yes.
So these 2 side ones.
And that is 136.
136. So we have 136, 2 of those. So this is 136. Whoa. Centimeters squared. There we go.
And then we got
I'll get
16
some better
times
units in there.
11.7.
Yes.
Okay.
And that's going to be the front and the back.
Okay. Sweet. 187.2.
Oh, that was what we had up here before,
Yes,
remember?
it is.
Yes. 187.2. So this is, I'm going to try to write it in here too. 187.2 centimeters squared. Okay. So basically what we've done is we've taken 2 sets of each of these. A lot of times if you've already found your base area, you can use it for volume and 2 of these already surface area. But then I kind of draw the pictures, because what if you had a triangle? What if you had something else? And the more pictures you can say whatever you have instead of just putting all the math on your calculator or something, you're going to understand it better. So let's do 2 times, we can do this in our head, right? 2 times 100 is 200 minus 1, so 199.
Yes, 199.
Centimeter square, I'll start putting units in again.
Sounds good.
What is that, 272?
Yeah, 272, yes, 272.
I might do it on for this one for fast. 2 times 187.2. Can do it, but
7.2. Who cares?
Sometimes, yeah.
374.4.
374.4 centimeters squared, and we add it, and the total surface area around this whole little
272 plus
flash box.
199 is 845.4.
845.4.
And now we're talking
centimeters squared. So there's more like volume here with the little squares, but then we have cubes, right? These little centimeter cubes, but then now we're just talking square. 2-dimensional, your pinky finger. And that's gonna go around the whole outside. Around.
Nice.
Cool. So that's called a rectangular prism. And we're going to do the similar thing, but we're going to do it with a triangular prism next. Which we have Toblerone.
A delicious treat.
Try to open it.
Sure.
And then I will switch the screen so we can start again.
All right.
Plus.
Okay.
There we go.
It's made in Switzerland, everyone. All right. Oh, look at all the little notches.
Yeah, we can even. Yeah, but we're gonna do the whole thing.
We're gonna ignore the notches for now.
Whole little Toblerone.
Okay.
Okay. So first, we're gonna do our base area. Now, what people forget, we're gonna pretend it's all connected for all the point. Like pretend it's all filled in.
Yeah.
Like if it was still in the package, right?
Okay.
But what happens is it's actually hard to find real life things like this that aren't like just a math thing.
Right.
But anyway, it's kind of fun to do. Anyway, so basically your base area is a triangle. So some people try to say base area is like this rectangle, but then, that base doesn't go all the way up. So, we want that triangle down. So we're gonna find the base area, so we just have to do base. Here, I'll hold it actually.
So I just have to do this once and times 3, right? It's pretty, is it even, or we're gonna find out? This is 2.7.
2.7, and then we need a height down the middle, perpendicular to the base.
Wait, where are we doing?
We're doing the height of the triangle.
Oh, yes,
so you have to do it perpendicular to the base, the best you can.
Okay. That was 2.7, this is 2.4, 2.3?
Okay, 2.7, 2.3, sounds good.
2.7, 2.3.
And I'll draw a little picture of that. 2.7, 2.3. Triangular prism. Because we're naming it by the triangle, the congruent parallel bases, and the base area for a triangle is base times height divided by 2. All triangles are half of rectangles. If you drew this, triangle's half, no matter if it's like this. This one's like this. So our base was what, 2.7?
Yeah,
and our height is 2.3. So it's 2.7 times 2.3 divided by 2.
Okay.
That's going to be our base area. But notice the base has to be perpendicular to the height has to be perpendicular to the base, because for the height you want the whole thing from top to bottom and from right to left. But it's always half.
I got 3.1.
You did the 2.7 times 2.3 divided by 2. And what do you get?
Yes, I did.
What was it? Sorry.
Oh, that's okay. 3.1.
3.1, and that's going to be centimeters squared. Much less than our flash box.
Yes.
So now we're going to do our 2 things. So first we'll start with volume.
But I mean, compare the 2 of these.
Yes. Volume is going to be, that's our base area times height, and our base area is about 3.1 centimeters squared.
So I get to measure the height of this, which is really this thing, right?
Yes.
Okay, cool. Let's get it to the right.
Obviously, you're going to lose some of it with all the gaps, but...
Yeah, gaps, we don't care. 10.3. 10.3 is the height.
If you were talking about the whole thing filled into, if we had measured the outside of the package, it's more what they fill in inside the package.
Right.
Yeah. And what is that?
10.3
times 3.1.
Times 3.1. 10.3. 10.
It's pretty cool.
3 times 2.1 equals 21.63.
So about 21.6.
Did I mess up? I did. Don't tell me that. Hold on. I did.
Yeah, that does
I
seem...
did 3. It's 3.1 times 10.3. I did 2.1, 3.1.
That makes sense.
Times
you know how we realize that? Because we got
10.3.
20 and it's 10 times 3, so that'll be higher than 30. That's
31.9.
what we do when we have to think outside of it.
Yes,
Go ahead,
yes.
Sarah.
31.9.
31.9 centimeters cubed. Now
Okay.
that's interesting because if we go back,
Yes.
1,592 to 31. Right?
yes.
So that's what, 50?
Look what we did though, like you said, a rectangle. This is
Yes.
rectangles, 2 of these.
What?
Well, I mean the rectangle. You said the triangle.
Yeah,
is
it's
like
half. So if we don't, yes, if this
Half.
was a whole entire, but you did fill in both sides. But yeah, let's go ahead and try surface area then.
Okay.
So the surface area is going to be interesting because we're going to have to find this bottom one, and then we're going to have to find this. But it looks to me like it's an isosceles trapezoid or isosceles triangle. Actually, we'll look. I mean, you can measure again, but it's about 2.5.
2.5.
Yeah, and they want it. I mean, you kind of tell that it's isosceles.
Which
triangle.
just means equilateral.
It means equal. No, equilateral will be all 3. Oh, is it all 3? Oh.
I don't know. I just was asking. Is that guy a lot
But
wider?
it seems
It's wider?
long. It seems a little bit longer.
'Kay.
Remember, we did 2.7.
Okay.
It's either equilateral or isosceles. We will find out right now.
Okay.
So we're going to do total surface area, which I'm not going to remember what it is again because we're doing it the second time. So I need 2 bases, and in this case, I'm going to need like 3 rectangles. So I'm going to need. I'm just going to put this rectangle plus this rectangle, pretending we don't know, plus this rectangle. Because we don't know if they're the same, but we're going to find out if they're the same.
Okay, we're going to find out.
Okay, so let's do the back one first.
All right. What am I doing?
Looks like there's almost nuts in this.
I know.
I don't remember.
We're kind of drooling here. It
Forever.
looks like nuts in this. It's almond nugget.
There we go.
Okay.
What is that?
That's
20? Is that the 2.7 one we're
2.7.
using?
Yes,
Okay.
2.7.
And then this is the height that we use too.
This is the 10 point something.
10.3.
10.3. That's right.
So this is the 2.7
Yes. 10.3.
times 10.3. And we'll figure that out. And then we need the 2 side ones, but I believe they're going to be the same.
Okay, go ahead.
Or we can hold it. So this is going to be our 10.3.
Yes. That's our 10.3.
But then we want to do this length, which I believe is where I was seeing the 2.5. What do you think? 2.5? 2.7? Maybe it is?
2.7, I think, only because we did this a little
it
bit.
is equilateral. Oh, that's
It's equilateral.
cool.
Nice.
Oh, that's
Okay.
cool. Who knew?
We've already done
I
some
learned
measuring.
something about...
It's easier for us.
Oh, then these are all the
They're
same
all the same.
then. Oh, that's fun. So they're actually 3 are the same. So you can, once you figure that out, write 2 bases plus 3 rectangles. But regardless,
Yes.
can you figure out what 2.7 times 10.3, and I'll write down the 2 bases.
Yes, I certainly can.
31.9
times 10.3 is 27.8.
27.8, and then we have 3 of them actually.
We do.
So these are all 27.8.
And that's 83.
27.8. 27.8, and there's 3 of them.
And then when you do that, you multiply by 3, it's 83.4.
0.4, but we also need the 2 times 31.9.
All right, 2 times 31.9.
And I'll do the centimeters squared.
63.8.
63.8 centimeters squared, and we're going to add the 3 rectangles to the 2 triangles to get...
Add 83.4. 83.4 is equivalent to 147.2.
147, approximately 0.2 centimeters squared. So if we were to go around this whole thing, it'd be about 147 centimeters. Conversely, when we did the flash, it was 845 centimeters to go around this whole thing.
Yes.
Pretty cool. And really with the, it is the surface area, you would take out all these scoops, which curves, but that's basically, if you think of how much was in this package.
Yes.
Space taken up. So now,
Nice.
we're gonna do a trapezoidal based
Oh, this
prism.
is the Kit Kat?
This is the Kit Kat. So
Remove the
I
Kit Kat?
tasked my children to find, things in real life. And like everything's just prisms. But
Yes. But this goes in.
that are
it
rectangular
slants.
prisms, but look, it's a trapezoid.
Oh, yeah, whoops. We gotta hold it sideways.
Sideways.
There you go. That was it.
Yes, 2 little trapezoids.
See, it's not straight up and down.
Hands in the way.
Yes. Yeah, there it is.
2 trapezoids.
Trapezoids.
So we can split it, and then we'll just
and that's what you do with the Kit Kat bar, right? Yes. Break me off a piece of that Kit Kat bar.
Yes.
Okay.
So this is called a...
Oh, I get to measure again.
Trapezoidal Prism.
Okay.
And first we need to figure out our base area.
Base area.
Now this is what's cool and why I wanted to get to the trapezoid. So everything on all these is like base times height. Base times height. We did triangles. Base times height divided by 2. Well, trapezoids have 2 bases. So what can we do to make it have 1 base? We can average it.
Take a bite. No, just kidding.
We can average it, and that's the problem when I teach this is students see this formula. I'm going to write it and then erase it.
Okay.
It's 1/2 h base 1 plus base 2 like this, but no students have never seen subscripts before.
Right.
That looks just super hard, and then my
Yes.
brain is like, well, we've been doing base times height the whole time.
Yes.
The logic is if you have 2 bases, you just average them and you just have base times height. Base times height for everything.
Okay.
You just do it a little different. So we're gonna measure the bases. So I will do the subscript just to explain it. So base 1
Okay.
is little 1, base 1
little
is...
1. Base 1, little 1 is...
I think I already did it. I think it was like 0.7.
It's tiny. I
0.9?
think... No, actually it's...
1?
We'll call it 1.
Yeah, 1.
1.
That's 1.
Okay.
1 centimeter, and then base 2.
Then the longer one.
Yeah,
the
maybe that was
wider.
the one that was like 1.5.
That's 1.5.
Okay. I think I was just measuring it just to see if it was like, they're so tiny.
Okay, yeah.
And then what's my height?
Oh, your height. Yes, yes. Okay. Your height is 0.9. That is 0.9.
0.9 centimeters. I mean, the others were more straightforward. I was like, I don't know if it's going to be too tiny with centimeters, but it's not. It has enough.
Okay.
So we're going to average the bases.
Okay.
And then times it by the height. And averaging means you add up how many you have and you divide by how many you have.
Okay.
So that's how I'm going to write it. So I'm going to do 1 plus 1.5.
Yes. So we know what that is.
And then I'm going to divide by 2, and then
Okay.
I'm going to times it by 0.9.
Okay.
So 2.5 divided by 2 is
2.5 by 2.
1.25, right?
Yes. Yes.
$2.50 divided by 2 is $1.25.
Yes.
So then, really what I have is 1.25 centimeters times 0.9 centimeters. And what's cool about that is it's almost like, I call it new base times height, or something like that. But really, you're just doing base times height. It just took you averaging. So you always do base times height, but sometimes you divide by 2, and sometimes if you have 2 bases, you have to average them so you can get that. All right.
It's 1.125. Is that what you want to
Oh, we're done. You did it. 1.25 times 0.9?
Yes, it's 1.125.
3.
1.13, yeah, okay, sounds good. Okay.
Does that make sense?
I don't know, did I do it right? Let's see.
No, it might be.
1.25
Yeah, no, it is.
0.9, yes.
But think about it. You have a whole centimeter would be that big, and you have to have it cubed. So it's a whole centimeter
so it's
cubed.
Almost 1 times
But it's like this, but cubed, but it seems like that should be bigger.
Does it?
1.1, we did 1.25. Yeah, it has to be smaller. That makes sense. 1.13. No, that's right.
0.9. Okay, good.
That's right. But I just accidentally, this should be cubed.
Okay.
All right, we're almost done. So total surface area means we do all of the outside. So total surface area, we need 2 bases still. Equals 2 bases. Oh, did we do? Oh no, that was my base area. I never did my height. That's why. That was just the area of my base. If we don't get to surface area,
Is
it's
this
fine.
all the way to height? Is
Yeah,
this
but
the
that's
height?
centimeter. Yeah, that's centimeters. There we go. That's why.
Oh, 6.6.
So that is just the area, but we never did.
We never did the height of this
We
whole
never
thing
did
to get the whole
volume.
length.
Yes.
Okay,
and
right.
if we stop with that makes sense. Logically, I'm like, there's more than a centimeter. That cubic centimeter and that whole thing that didn't make sense, which is why you keep going till it makes sense. Okay. We can just add in volume too. It's fine.
Good, add volume.
So volume is base area times height, which is 11.3 centimeters squared, which I was correct when I wrote that, times the height, which is
6.6 centimeters.
6.6. Just just need to change this back. I changed, it was squared and I was correct.
Oh, that's right, because we didn't include what we needed
yes,
to
times
make it.
height, which was, sorry, say it again.
Oh, 6.6 centimeters.
6.6 centimeters,
Yes, I
that's
got
the
it.
height.
Okay.
This is 1.13 though.
6.6
Whoa.
times. Is it 11.3 or 1 point?
It's 1.3.
I got it. 1.13, and I have the answer when you're ready.
1.13 equals about
7.46.
That makes way more sense.
Okay, good.
Yes, this makes sense that it is 3 cubic centimeters, not 1.
Okay, yes.
That's
yes.
much more likely.
Yeah, because otherwise it just makes you confused.
I mean, not
so
3,
tiny.
7 cubic centimeters. If you go down it.
Right.
1, 2, 3, 4, 5, 6, 7.
That makes sense. Yeah.
6.6 centimeters.
Close enough.
All right, yes. And then if we go back to this one, 31.9. So it's about 4 times as much volume. Could you have like 4 volume to get in here without the gaps? I think so.
I think you could too.
1, 2, 3, 4. That's pretty cool. It's about 4 times as much. So the total surface area, this one, it's not going to be that tricky, but you basically have to do rectangles on the, we'll just stop with this, it's totally fine.
Okay.
I wanted to practice with you on the screen of finding the area of a trapezoid. I have students that get very confused because the formula just gets put and it's just go quit. But if you know you have 2 bases, you average them, you just do base times height. But you'll do these 2 bases and then you actually have 4 rectangles, so you have 1 on the bottom, 1 on the top, and then this is actually an isosceles trapezoid, so these 2 on the side would be the same area.
Neat.
So actually I can write that. Let me write that. So this specifically is called an isosceles trapezoid. And isosceles means that 2 sides are the same. But you can do the same method, and then actually that first one, or that last one, this triangle ended up being all the same, and this is called an equilateral triangle because all 3 are the same. So it's just kind of good to get the vocabulary.
Yes.
Yeah, pretty cool. So
Nice.
the big idea, if I'll go back, is to draw the pictures. Draw that you have 2 rectangles. Draw those pictures. Draw that you have a triangle and 3 rectangles. And if you draw the pictures, it does help you. Drawing these diagrams helps because otherwise it's just too much math that gets squished. We almost forgot to do times height because it's just you have so much, math you're writing down. So just and check your answers and think logic. Can we? Is this whole thing 1 centimeter
Will it
cubed?
fit into something else?
Yeah, that
for
can't
sure.
be 1 centimeter cubed for the whole thing, but 7 makes sense.
Yes.
And it makes sense that 4 of these trapezoidal prisms fit into a triangular prism. So
today's been delightful, not only for the information, but also for the smell of the candy. Thank you very much.
And these are all prisms, and cylinders are similar to prisms.
Yes.
You still do base area times height. You just do pi r squared times height, but same process. Base area times height. I like when things are kind of uniform, especially when they are uniform. We don't have to make them so separate.
Nice.
So
cool.
anyway.
Hopefully this makes it easier for you guys to understand.
And
too.
this one you would probably split and do rectangles. I was thinking you'd split it into rectangles and you could add up all the rectangles.
Oh yeah.
But anyways.
Nice.
All right, have fun with math at home. You can find volume and surface area of all of your household games and
Very
such.
cool. So glad you guys tuned in.
Thank you for tuning in.
Thank
Bye.
you. See you.